We often picture scientific progress as a series of violent successions. A reigning theory sits on the throne until a new genius comes along, shatters the old ideas, and takes the crown for themselves. Scientific progress actually happens in a courtroom. We call theories to the stand as witnesses, asking them to testify about how the universe behaves under specific conditions. The math Isaac Newton published in 1687 was incomplete, but its testimony was accurate enough to drop an astronaut directly onto the lunar surface 3 centuries later. Older models survive because they managed to capture a genuine piece of the universe's structure. Their value depends on these reality-contacting features, even when the model fails to explain every detail. The Court of Theories serves as an ongoing, timeless trial where human ideas are continuously cross-examined by physical evidence. Every physical model goes through the same procedural loop. A crisis in our understanding occurs. A new idea walks through the door, and we audit its claims for theoretical debt before trying to build a bridge to the next framework. The rules of this courtroom are strict. Ideas enter for free, but promotion to a dominant, accepted domain costs intellectual debt. Think of it as a cosmic accounting ledger. A theory's assets are the real-world phenomena it successfully explains. Its liabilities are the anomalies it sweeps under the rug, the questions it cannot yet answer. A new scientific model earns its place on the stand when it acts as currency, successfully paying off the outstanding debts left behind by its predecessors. We call our first major historical witness to the stand Isaac Newton. He presents a unified mathematical grammar of motion, replacing a fragmented view of nature with calculable laws. This diagram illustrates his primary asset, resolving a massive celestial crisis. He proves that an apple dropping from a branch and the moon falling around the Earth are obeying the exact same gravitational rules. Under cross-examination, we see massive liabilities, action at a distance, and absolute time. The judge doesn't throw out the testimony. Instead, Newton's laws are scoped to the classical domain, valid for ordinary bodies at slow speeds. This is how a theory stays alive in the court. As long as its successes are carefully mapped and its unresolved debts are kept visible, it remains a permanent part of the scientific record. 2 centuries later, experiments failed to find the mechanical ether light supposedly traveled through. To address this crisis, the court calls Albert Einstein. He brings a new currency to the table, general relativity. He pays off Newton's old liabilities by proving that space and time are not rigid containers, but a dynamic, moving geometry that warps around mass. Yet, his own ledger eventually runs into the red. His equations break down at the center of black holes, creating mathematical singularities, and they clash with the erratic behavior of microscopic particles. Every successful explanation clears the books for a moment, only to generate the precise boundary conditions that will trigger the next great scientific crisis. Today, the trial is gridlocked. General relativity and quantum mechanics are both sitting on the witness stand, and neither can move forward. Both theories possess immense predictive wealth in their own domains, but they use contradictory languages. You have the smooth, curving grids of gravity on one side, and the jumping probability waves of quantum mechanics on the other. Neither framework holds the theoretical currency required to pay off the existing debts of the other. They are structurally incompatible. The current state of physics is a stalemate of rival witnesses, each guarding a brilliant but incomplete record of reality. The ultimate objective of this cosmic court is to find the theory of everything, a single mathematical grammar that unites the microscopic and the cosmic. As this page shows, we won't reach that answer by simply tossing out our current models. In the court of deep theories, progress requires strict forensic accounting. Researchers use lists like this for feature extraction. They identify the exact pieces of older theories that touch reality, like Maxwell's fields, ensuring they survive in future frameworks. The EBP workbench maps domains, tracks failures, and determines exactly what survives when connecting them. The theory that eventually claims the title of everything will be the one that finally pays the universe's oldest, most stubborn debts.